Now that we've seen how to set up the tableaus, we can jump right into solving. It's definitely worth reading through your book to understand this idea of basic and non-basic variables. Really what we're doing is we're exchanging those as we move around the feasible region. So you can imagine, and actually if you look at the example from last time and solve the simplex tableau from this time, you'll see that each solution you get from each step, remember, they're not all maximum optimal solutions, but each one is actually a corner point. You're actually moving around the feasible region checking corner points. And so what we do is we pivot. That's how we pull that off. The steps to pivot is a little strange. We pick the column with the most negative value with the objective function, that last row, and then we check ratios and we pick the one with the smallest. I think that's easier to see as we go, but if you want to see a step-by-step process through it, like a list of all the possible things that could happen, I would say check page 282 in your book. It has a really nice step-by-step exactly what you're going to do list. It takes up the whole page though. Like I said, it's a little bit easier to see. So we'll start out with one that I would say is pretty easy. It's real straightforward. It's got one pivot before we get the optimal solution, just to get the idea, and then we'll do a more realistic one. So of course my first step is to set this up. And so I got to write the equations and all that. I already did that, so what I'll do is I'll write down the tableau that I get. But notice we have two constraints, so we're going to end up with two slack variables. And so you should double check that you get the same thing when you set this up. But what I get when I set it up is x1, x2, s1 and s2, z. And then for that first constraint, I get 1, 1, 1, 0, 0, 5. For that second constraint, I got 1, 5, 0, 1, 0, 13. And then remember, I had to rewrite my objective function. So when I did that, I got -1. I got a +3 because of that -3. 0, 0, 1, 0. Okay, so each time you pivot, you're essentially checking another corner point. You start out at 0, 0, well, at least if you're in 2D space. So right now, the current solution is x1 equals 0, x2 equals 0, z equals 0. Anytime your x1 and x2 are not a unit column, they're currently at a value of 0. A unit column would be like S1. Right now, S1 is 5 because it's a unit column and that's where the 1 is. And S2 is 13. But we want to know what X1 and X2 are. And right now we have X1 and X2 equal to 0 and Z equal to 0. Definitely not optimal because we could probably be bigger than 0 for Z. So down here, this is the current value for Z because of that 1 right there. Okay, so to pivot, what you do is you pick the most negative entry in the last row. Well, there's only one. Well, I told you this one's kind of easy. And so there's my most negative entry. And then you're going to check ratios. You're going to divide this last entry, 13, by the entry corresponding in your pivot column, and that'd be over 1. Okay, being as easy as it is, it's 13 over 1, which is 13. And same thing here, the 5 divided by this entry, which is 1, and you get 5. So what you're going to do is pick the smallest one. You're going to pick the row that gave you the smallest, and that would be row 1. So this means I'm going to pivot this entry. I want this to be a 1, I want this to be 0, and this to be 0. So notice, by the way, that it's already a 1, so that's kind of nice. So what I want to do then is do my row operation. So to do my row operation, what I'm going to do is just like before. I'll keep this a 1. I'm going to get rid of this one by subtracting row 1. And I'm going to get rid of this one by adding row 1. Okay, and so let's see what happens when I do that. This is essentially moving to another corner point. That's one way to think about it. So this first row is going to stay the same. This is now 0 and 4, -1, 1, 0, and then 13 minus 5 is 8. And then down here I'm adding, so I get 0. I get 1 plus 3, I get 4. Down here I get 1. Here I get 0, here I get 1, and then here I get 5. Okay, right now I know I have an optimal solution. I'll explain that in just a second. But let me relabel these since I'm done. X1, X2, S1, S2, and Z. All right, the reason I know I have an optimal solution is because there's no more negatives in the last row. As soon as you run out of negatives, you've found your optimal solution. Now, if you can't pivot anymore, I would always double check to make sure you didn't mess up because there can be many steps, especially in a problem like this where we had only one pivot. But again, I'm looking here and I have no negatives. So I have to be at an optimal solution. So okay, so now the question is, what is the solution? How do I read this off? Well, if you have a unit column, you're looking for where that 1 is. So this is telling me x1 is equal to 5. Okay. So we have an optimal solution. x1 equals 5. And now x2 is not a unit column. That means it automatically is 0. And now S1 and S2, S1 0, S2 is 8, but we don't care. Those were just variables we needed for the process. The solution, it doesn't affect our actual Z. And here Z is 5. This is your optimal solution right here. Another way to say this is we reach a maximum of Z equals 5 at x1 equals 5 and x2 equals 0. So if you were to do this graphically, what you would find is that corner point 5, 0, if you were to make a corner point table, would actually give you the best value. So like I said, if this happens to you, do one pivot, I would go back and just double check real quick that it was that easy. This time it was. Most of them are going to be that you do 1 or 2 pivots, possibly as many as 3, but real life problems can be many, many pivots. And so we practice on the simpler ones to understand the process. I do think, though, we should go through one that's a little more realistic in difficulty. So this showed you the idea, but let's look at one that's more realistic. The first thing I noticed with this one is that we have 3 variables, but we only have 2 constraints. That means I'm going to have 2 slack variables. And so when you go through the setup, which I totally recommend you go through and do, you're going to have x1, x2, x3, but you're only going to have s1 and s2. And then, of course, you're going to have z. So from that first constraint, you're going to have 1, minus 3, 5, 1, 0, 0, and then 50. From the next constraint, you're going to have 2, 4. There's no x3. You got to be careful there. No x3. 0, 1, 0, 40. And then remember your objective function. Everything gets moved over. So it's minus 8, minus 6, minus 8, 0, 0, 1, 0. Okay, here's my initial tableau. So that's how I would describe this. This is your initial tableau. So again, notice x1, x2, x3, they all currently equal 0. You're at that corner point 0, 0, 0. All right. So now the question is, which column do I pivot? That's what I got to start doing. Well, I picked the most negative, but there's 2 choices, right? When there's 2 choices for the most negative, you can pick either one. So one might be a better idea than the other. It's really hard to say. I'm going to pick the first one just because, but you could also pick this next one. Sometimes if you pick the right one in a way, it will be less work, but other times they're the same. There's no way to tell ahead of time. So I'll just pick this one. I'm going to say, okay, well, I'll pick the minus 8 here. Now, if this was minus 7, minus 6, minus 8, then I'd pick this one. But since they're equal, I have a choice. Now, to pick this, I got to divide. So I got to choose the smallest, 50 over 1 versus 40 over 2. Okay, 40 over 2 is obviously smaller. So I'll be pivoting this row. What you would say here is that the pivot entry is 2. You're pivoting on the 2, essentially. So I'm pivoting this value, okay, where they overlap. Well, that value currently is not 1 like the previous one. So what I got to do is a quick row operation to make that 1. I got to multiply by 1/2. So you should be multiplying here to make that happen. All right, when I multiply by 1/2, I get the following. The first one didn't change. The next one is now 1, 2, 0, 0, 1/2, 0, 20, and then I didn't change this one either. And again, you don't have to label your columns every time. I like to put the lines there, though, so I can keep track of what's what. Now, I got to remember which one I'm pivoting on. So remember, I'm pivoting this entry right here. So I'm going to use that to get rid of everything above and below it. When you pivot, you're basically making it a unit column. So what I need to do here is subtract row 2. And what I need to do here is add 8 times row 2. And this will take me to my first, or well, really my second basic feasible solution. So when I do this, I'll just tell you the values that I get. I get 0, minus 5, 5, 1, minus 1/2, 0, and 30. Okay, so again, that was this operation minus row 2. So I subtracted, nothing happened here, nothing happened here, subtracted 1/2, nothing happened here, and 50 minus 20 is 30. Remember, you're not changing this at all, so you leave it alone. And by the way, it's totally okay to use fractions as you go. I tend not to, but it really doesn't matter. And now for this last one, remember, I'm doing 8 times row 2, so I'll have 0 here. I'll have 10 here. I'm going to have minus 8 here because that 0 above it does nothing. 0, 4, 1, and 160. What I have right now is, again, a basic feasible solution. x1 is 20, x2 is 0, x3 is 0, and z is now 160. So by doing this pivot, we increased the value of z, so we got closer to a maximum. However, I know this isn't the biggest that z could be because of this -8 right here. Now, this isn't related to having the -8 back here. It doesn't mean if I started here, somehow it would have gone better. Although you can try, maybe that's true in this case, but it doesn't mean it in general. This just happened to work out this way, mainly because of that 0. So now I got to decide, okay, what am I going to pivot? Well, remember, the -8, most negative. I don't have an optimal solution yet because I still have a negative in the last row. And now I got to take a look at my ratios, right? 20 over 0. Please don't write that equal to 0. 20 over 0 is undefined. It is not equal to 0. This is undefined. Does not exist. You will never pivot on something where you divide it by 0. 30 divided by 5 is 6. We have to pivot there because 20 over 0 does not exist. Remember, it does not equal 0. So I say, okay, I'm going to be pivoting on this first row. So unfortunately, that's a 5 where I need to pivot. I need that to be a 1. So the reason I say unfortunately is that means I got to multiply by 1/5. Looking at the numbers, though, this might not be as bad as I think, but I certainly would be having a calculator around just to double check my work. So when I do that, I got 0, minus 1, 1. I get 1/5. That's not a big deal. Okay, I get minus 1/10. It's a little annoying. And then I get 0, and then 6. And remember, I didn't do anything else yet. So 1, 2, 0, 0, 1/2, 0, and 20. And then finally, my last row, the very important one, 10, minus 8, 0, 4, 1, 160. Okay, so remember, this process is going to increase that 160. That's kind of our goal, right? So now I got to remember which value I was pivoting on. I was pivoting on what was a 5. It's this entry right here. What's really nice about this, though, is that this -8 is the only thing I have to worry about. We already got a 0 here. So I only have to do one row operation. I have to add 8 times row 1 right here because I already got a 0. Your goal is to make this a unit column. That means I got to do a lot of copying down, though, first, because I'm not doing anything to the first 2 rows. So I got 0, minus 1, 1, 1/5, 1/10, minus 1/10, 0, 6, and then 1, 2, 0, 0, 1/2, 0, 20. And then, okay, let's do this row operation. I get 0, because 8 times 0 is 0. I get -8 and 10, right? So 8 times -1 is -8 and 10. So I get a 2. 8 times 1 is 8, and -8, I get 0. 8 times 1/5 is 8/5. Luckily, there's a 0 here, so that's just 8/5. Okay, 8 times -1/10 plus 4. I totally did this in the calculator. I got 16 over 5. And then 8 times 0, of course, is 0, so the 1 stays. And 8 times 6 is 48, but then I got to add that to 160. And when I do that, I get 208. So notice, again, my z increased. And this is an optimal solution here because notice I have no more negatives down here in the bottom. So that's a 208. I don't know how easy that is to read, but 208. Since I'm at my optimal solution, what I'm going to do is remember my variables. So I had x1, x2, x3, and s1 and s2 and z. All right, so what I see here is that I have a maximum of 208 at the point, x1 equals, and so x1 is a unit column, so I just read where the 1 is. x1 is 20. x2 is equal to, well, it's not a unit column, so 0. And x3, look where the 1 is, it's a unit column, equal to 6. So I think this really reminds me a lot of working with matrices in general. Not one step was particularly hard, but again, I think the phrase computationally complicated, perhaps, or involved would be true. We have to be careful about calculations here. But overall, it's a very organized process, and you're guaranteed to get a solution if there is one. So there can be situations where there is no solution, and you'll see that quickly because you will have nothing to pivot on. And there's a couple of examples in your textbook like that too. So definitely go through these, practice. I would redo this, make sure you get the same values I did. And again, you're always looking for that value of z to increase. So if that doesn't happen, something else happened.